Hi friends, in my previous video I already explained about motor. And I also said that the generator will be exact opposite to the motor. So what is the difference between the motor and generator, you will come to know by observing the two videos. So motor I already finished, so motor link I will give you in this description. Next, coming to today's topic, it is about generator. So I have taken the topic same, electric generator and alternating DC currents. So there are two types of generator, friends. One is alternating current, another is direct current. So we will call generally AC and DC. So generators can produce AC and DC. Let's go to our topic. So for this total generator of AC, first we are seeing the AC generator. So coming to AC generator, we require the two magnets, permanent magnets, and same coil, one rectangular coil. Next, slip rings, and this slip rings is attached to the brushes, two brushes. Next, it is connected to the coil where the current can be passed. So whatever the current it is producing in this coil, it passes to the slip rings. Next, it passes to the brushes, and it passes to our electrical equipments or the battery wherever you want to store. So this is the total process of generator. Next, let's go to step by step process. As usual, I will explain step by step, and finally I will explain one more time. No need to worry. So for your more understanding, try to see the video up to last. Don't skip anything. So first point, see, consider a rectangular coil. Let it be held between the poles of curve shaped permanent magnet as shown in figure. So it is saying where the coil should be placed. So it should be placed in between of two curve shaped magnets. So we have seen. Next, as the coil rotates, the magnetic flux passes through the coil changes according to the law of electromagnetic induction, and induced current is generated in the coil. So friends, if the coil which is placed in between of two magnets, and this coil, whatever the coil it is placed in the magnetic flux will get changed with the help of the coil. So in this case, what happening, whenever any magnetic flux it is getting disturbance or it is getting changed due to any coil, then current will be induced in the coil. So this is we have seen, and this current is called induced current. This all we have seen in the Faraday's law. So Faraday's law's video also I have done, so that video link also will give in the description, try to check. So we have understood now. See, two magnets are placed. In these magnets, coil is placed. If the coil rotates, the magnetic flux get changed and current will be induced in the coil. This is the total we have seen now. Next, consider initially the coil positioned in such a way that magnetic flux passes through it. When the coil is in rest in vertical position with side A of the coil at top position and side B at the bottom position, so no current will be induced in it. Thus current in the coil is zero at this position. So friends, for this, see, they have taken one graph for easy understanding. I will explain for this point. See, if the coil it is placed perpendicular to the magnetic field, so what happens in that case, the A it will be on the top and B it will be at the bottom. In this case, there will be no induced current, so the current will be zero in this position. Next, coming to second point, when the coil is rotated in clockwise direction, current will be induced in it and it flows from A to B. During the first quarter of the rotation, the current increases from 0 to A maximum and reaches peak value when the coil is in horizontal position. So friends, after some time the coil it rotates. So it rotates means what happens? This point, check this. So if coil is rotating, the A which is at the top, it changes its position. It comes to its right position, and B which is at the bottom, it moves to the left. So in this case, the coil is in parallel with the magnetic field. So in this case, we can observe that current will be produced, and this current will be in the graph form. See, in the graph form we can observe that it is increasing order. So this is the form where the coil will be parallel to the magnetic field. Next, third point, if we continue the rotation of the coil, current decreases during the second quarter of the rotation and once again becomes 0 when the coil comes to vertical position with side B at the top, A at the bottom position. During the second part of the rotation, current generated follows the same pattern as that in the first half, except that the direction of the current is reversed. So friends, for this I will explain. See, next, after completing that A and B parallel to the magnetic field, next it rotates. So after taking some rotation, what happens? Whatever the B, previous it was in bottom side, but it comes to now top, and A, previous it was on the top, it comes to bottom now. So as the coil is taking in this position, it is the perpendicular to the magnetic field. So in this case, the current, whatever it is in maximum, it decreases and it reaches to 0 again. Next, if the coil again rotates, what happens? The A, it becomes again parallel to the A and B, it becomes again parallel to the magnetic field. Next, the current will be induced in the coil up to maximum in the reverse direction. Exact reverse you are getting in this case. Next, again if the coil it is taking the vertical position, what happens? The A, it will goes to the top and B again at bottom. In this case, it reaches to the 0 position. Like this, one complete cycle will be produced. This is one complete cycle equal to 360 degrees. So simple friends, for this total graph I will say, see, if the coil is perpendicular to the magnetic field, no current will be produced. If the coil is parallel to the magnetic field, current will be induced. This is the total about AC generator. Next, so some points they have taken, see, as shown in figure A. So about the figure they are saying, so whatever the figure we have taken in this about slip rings, they are saying, see, this construction is different in AC generator and DC generator. This is the basic difference between AC generator and DC generator. Once check, here two commutators has taken and means two slip rings, they are parallel to each other. This is the difference you will observe. So based on this diagram, the point is explaining. As shown in 17a, the ends of the coil are connected to two slip rings. Two carbon brushes are arranged in such a way that they press the slip rings to obtain the current from the coil. So this point we have seen. So the brushes use is to collect the current or to donate the current to the commutator. But as it is generated, it collects the current from the slip rings. When these brushes are connected to external devices like TV, radio, we can make them work with the current supplied from ends of the carbon brushes. So we have seen the current is getting observed from the brushes. So these brushes are connected to the devices whatever we are using. So our devices like TV, radio will work whatever the current it is producing by the generator. This is the total about. Next, the current obtained by this process changes its direction alternatively for each half cycle as shown in figure 17b. So once check the figure, we have seen in first half cycle it is reaching on the positive side. In next half it is going to the negative side. It is alternating. So this is called as alternating current, we can observe. So this current is called alternating current, in which the direction of the charge flows reversely periodically. So AC possesses certain frequency. The generator that we discussed here is called as AC generator. So according to the generation of the current, they are given the name. See, it is the AC generator. Why? Because the current here it is generating is alternatively. One half it reaches the positive, another it reaches the negative. So by this the current got its name as alternating current, and the generator whatever it is generating alternating current, it is called as AC generator. Next, the DC generator we will see. I already said in DC generator the construction is the slip ring thing. It differences from DC and AC. So in AC we have seen the two slip rings are connected in parallel, but here see the only single commutator is taken with off cutted commutators. So let's go to our DC. If two off slip rings are connected to ends of the coil as shown in figure 17c, the AC generator works as DC generator to produce DC current. So if you change the previous AC generator connections into in this way, off was, and it is connected to the brushes and it is connected to any electrical devices, then whatever the current will be generated, this current is called as DC current. So it's simple friends, change the slip rings. If you change the slip rings of AC to DC in this form, then this produced current is called as DC current. So this is about total this paragraph. Next we will see what is the directions of the current in this DC. When the coil is in vertical position, the induced current generated during the first off rotation rises from 0 to maximum and then falls to 0 again. So friends, this total paragraph I will explain. As the coil moves further from this position, the ends of the coil go to the other slip rings. Hence, during the second off rotation, the current in the reversed in its coil itself. The current generated in the second off rotation of the coil is identical with that during the first off of the direct current as shown in figure 17d for one revolution. So friends, total opposite of ACC, we can observe that in AC, if the coil is perpendicular, there is no current. If it is parallel, there is a current. But coming to DC, if the coil is parallel to the magnetic field, no current. And if the coil is perpendicular to the magnetic field, then current induced. Friends, till now we have seen the 2 points. So let us check whether these 2 points are satisfying with the graph or not. So let's see. So I will say simple, see, if A is on the top, if B is on the bottom, or if it is in reverse, B is on the top and A is in the bottom, it indicates that the coil is parallel. See, simple, they are saying that if the coil is parallel to magnetic field, then there will be no current. So here you can observe it is 0. In the coming to next case, the coil it changes. See, suppose if it is in parallel, now it changes to perpendicular to the magnetic field. So in this case, what happened? If coil is perpendicular to the magnetic field, here you can observe, see, the commutator, it is perpendicular. So if it is perpendicular to the magnetic field, then we can observe that the current will be increases and it is induces in the coil. This is the case. Next, if the coil again it changes, again if it gets parallel to the magnetic field, so here we can observe if it is parallel to the magnetic field, what happens? Whatever the current is at the top, it tries to reach its bottom level, means it reaches to the 0, means 180 degrees you will get here. Next, in this case, as the sibling, whatever the slip ring it is connected, the current will be reversed in this only in the positive direction only. So as you got in AC, the next current in reverse, that is negative direction, but in DC you will get the current after 180 degrees in the same positive direction. This is the basic difference in AC and DC. So let us go to this graph points. So if the coil is again perpendicular, that is A and B perpendicular to the magnetic field, then we can observe that again the current will be increases and it induces, it reaches to 270 degrees. Next, again if the coil it reaches parallel to the magnetic field, then we can observe that the whatever the current it is induced, it reaches to 0. Like this it goes on, means the cycle it continues in the DC generator. All the current values will get in the positive way. So this is the basic difference between AC generator and DC generator. Next, I already said generator means it is a device which converts mechanical energy into electrical energy. So whatever the videos we required for this total understanding, that is motor and Faraday's law, I will give in this videos link description. Try to check. I hope you have understood the DC generator and AC generator.